Hello everyone, welcome back to my channel. I hope you guys are doing great. Let me ask you something. Imagine you are a doctor working in a hospital. Every day, hundreds of patients visit you. For some patients, you already know their symptoms and final diagnosis. For example, fever, cough, breathing difficulty, and later confirmed as pneumonia. Over time, after seeing thousands of such cases, you become very good at predicting diseases. Now imagine a different situation. You are given thousands of patient records, but nobody tells you what disease they have. You simply look at the data and start noticing patterns. Some patients have similar symptoms, some belong to similar age groups, some have similar health conditions. You start grouping them together. Interesting, right? In both situations, learning is happening, but the learning approach is completely different. And that brings us to one of the most important topics in machine learning: supervised learning and unsupervised learning. If you are planning to become an AI engineer, machine learning engineer, data scientist, or work with generative AI technologies, understanding these concepts is absolutely essential. And the best part is that these concepts are actually much simpler than they sound. In this video, we will understand both concepts using practical examples, real world scenarios, AI applications, and interview questions. So let us get started. Before we jump into the concepts, let us first understand why this topic matters so much. Many beginners start learning artificial intelligence and immediately jump into deep learning, neural networks, ChatGPT, or large language models. But after a few days, they become confused because they skip the foundation. Learning AI without understanding supervised learning and unsupervised learning is like trying to build the second floor of a house before building the ground floor. These concepts are everywhere. When hospitals predict diseases, when banks detect fraud, when e commerce companies understand customer behavior, when cybersecurity systems identify suspicious activities, when AI models learn patterns from data, you will find either supervised learning or unsupervised learning working behind the scenes. That is why interviewers ask these questions so frequently, and that is why every AI professional must understand them. Now, let us start with supervised learning. The easiest way to understand supervised learning is to think about school. Imagine your mathematics teacher gives you a worksheet. Every question already has a correct answer. You solve the questions, then you compare your answers with the correct ones. If your answer is wrong, you learn from your mistake. After enough practice, your accuracy improves. Eventually, you become very good at solving similar problems. This is exactly how supervised learning works. The machine receives examples where both the input and the correct output are available. The model learns the relationship between them. Then it uses that knowledge to make predictions on new data. Let me give you a simple example. Suppose a hospital wants to predict whether a patient has diabetes. The hospital has thousands of records. Each record contains information such as age, weight, blood sugar level, blood pressure, and diagnosis. The diagnosis is already known. The model studies these examples. It learns which patterns are commonly associated with diabetes. Then, when a new patient arrives, the model predicts whether the patient is likely to have diabetes. Notice something important here. The correct answer was already available during training. That is why it is called supervised learning. Someone is supervising the learning process. The machine learns from examples that already contain answers. Now, here is where things become interesting. You probably interact with supervised learning every single day without realizing it. When a bank predicts whether a transaction is fraudulent, when a hospital predicts a disease, when an insurance company predicts claim risk, when a weather system predicts tomorrow's temperature, when a company predicts future sales. All these systems are learning from historical data where correct answers already exist. That is the power of supervised learning. The model learns from the past and predicts the future. Now, there are two important categories inside supervised learning. The first category is classification. Classification is used when we want to predict categories. Let us say a hospital wants to determine whether a patient has a disease or does not have a disease. The answer belongs to a category: yes or no, disease or no disease, fraud or genuine, approved or rejected. These are classification problems. The second category is regression. Regression is used when we want to predict numbers. For example, predicting the price of a house, predicting monthly sales, predicting rainfall amount, predicting electricity consumption. The output is a number rather than a category. A simple trick to remember this is: classification predicts labels, regression predicts values. Many interviewers ask this question, so make sure you remember it. Now, let us move to unsupervised learning. This is where things become really exciting. In unsupervised learning, the machine does not receive correct answers. There are no labels, there are no predefined categories. The machine simply receives data and starts searching for patterns. Imagine you are entering a large bookstore for the first time. Thousands of books are lying everywhere. There are no sections, no categories, no labels. Your task is to organize them. You start observing similarities. Some books are about technology, some are about business, some are about history, some are about science. Without anyone helping you, you create meaningful groups. That is exactly what unsupervised learning does. It identifies hidden patterns and relationships within data. Let me give you a practical business example. Imagine a shopping mall with millions of customers. The company wants to understand customer behavior, but nobody knows how customers should be categorized. So they use unsupervised learning. The AI analyzes customer data, purchase history, visit frequency, spending habits, product preferences. Then it automatically discovers groups. One group contains budget conscious shoppers, another group contains luxury shoppers, another group contains frequent buyers. Nobody manually created these groups. The AI discovered them automatically. That is unsupervised learning. One of the most popular techniques in unsupervised learning is called clustering. Clustering simply means grouping similar things together. Think about your phone gallery. You probably have thousands of photos. Imagine manually organizing every image. That would take forever. Instead, AI can automatically group similar images together. Family photos in one cluster, vacation photos in another cluster, food photos in another cluster. The system identifies similarities and creates groups. That is clustering. And clustering is one of the most common applications of unsupervised learning. Now let us understand another interesting application: anomaly detection. Suppose a bank customer normally spends between 1000 and 5000 rupees every day. Suddenly, a transaction of 3 lakh rupees appears from another country. The system notices that this behavior is very different from normal activity. Nobody explicitly taught the AI about this specific fraud pattern. The system simply recognizes that the transaction is unusual. This is anomaly detection, and anomaly detection is widely used in banking, cybersecurity, manufacturing, and healthcare. Now, let us compare supervised learning and unsupervised learning side by side. In supervised learning, data contains labels. In unsupervised learning, data does not contain labels. In supervised learning, the machine learns from correct answers. In unsupervised learning, the machine discovers patterns independently. In supervised learning, the goal is prediction. In unsupervised learning, the goal is discovery. Supervised learning answers questions like: will this patient develop diabetes? Will this customer buy a product? Will this transaction be fraudulent? Unsupervised learning answers questions like: what hidden customer groups exist? Which users behave similarly? Which activities look unusual? Different goals, different approaches, both equally important. Now, let us connect this with artificial intelligence. Artificial intelligence is the broader objective of building systems that can perform tasks requiring human intelligence. Machine learning is one way of achieving that objective, and supervised learning and unsupervised learning are two of the most important machine learning techniques. Without them, modern AI systems would struggle to learn from data, whether it is healthcare, finance, transportation, education, cybersecurity, or retail. These learning approaches form the foundation of intelligent systems. Now you might be wondering where deep learning fits into all this. Deep learning is a specialized branch of machine learning. It uses neural networks inspired by the human brain. The interesting part is that deep learning models can learn using both supervised and unsupervised approaches. For example, a medical image analysis system may use millions of labeled X ray images. That is supervised learning. At the same time, some deep learning systems learn hidden features and representations without labels. That is closer to unsupervised learning. So, deep learning is not replacing these concepts, it is built on top of them. Now, let us talk about generative AI. This is the topic everyone is excited about today. Tools like ChatGPT, AI coding assistants, AI image generators, AI voice generators, and AI research assistants are all examples of generative AI. But have you ever wondered how these systems learn? Think about it for a moment. Before ChatGPT can answer your questions, it first needs to understand language. It learns from enormous amounts of text data: books, articles, websites, research papers, conversations. During this phase, the model learns patterns in language. It learns grammar, sentence structure, relationships between words, context, meaning. This learning process resembles unsupervised learning because much of the data does not contain explicit labels. Later, human experts provide examples of good questions and good answers. The model learns how humans prefer responses. This stage involves supervised learning. That is why many modern generative AI systems use both learning approaches, and that combination is one of the reasons they are so powerful. Now, before we wrap up this video, let us go through some interview questions that are frequently asked. Question number one: what is the main difference between supervised learning and unsupervised learning? Answer: supervised learning uses labeled data, while unsupervised learning uses unlabeled data to discover hidden patterns. Question number two: can you give a real world example of supervised learning? Answer: disease prediction, fraud detection, weather forecasting, and sales prediction are common examples. Question number three: can you give a real world example of unsupervised learning? Answer: customer segmentation, clustering, anomaly detection, and market basket analysis are common examples. Question number four: what are the two major types of supervised learning? Answer: classification and regression. Classification predicts categories, regression predicts numerical values. Question number five: what is clustering? Answer: clustering is an unsupervised learning technique that groups similar data points together based on their characteristics. Question number six: why is unsupervised learning useful? Answer: it helps discover hidden patterns and relationships that humans may not easily notice. Question number seven: can deep learning use both supervised and unsupervised learning? Answer: yes. Deep learning models can be trained using either approach depending on the problem. Question number 8. Do large language models use supervised learning or unsupervised learning? Answer. Most modern large language models use a combination of both approaches during different stages of training. Before we finish this video, let us quickly go over everything we learned today. We started by understanding why supervised learning and unsupervised learning are so important. Then we learned that supervised learning works with labeled data and focuses on prediction. After that, we explored unsupervised learning, where machines discover hidden patterns without predefined answers. We discussed practical examples from hospitals, banking systems, shopping malls, and cybersecurity. We also learned how these concepts connect to artificial intelligence, machine learning, deep learning, generative AI, and large language models. And finally, we covered some important interview questions that can help you prepare for AI interviews. Now, you might be wondering where you will actually use this knowledge in your career. The answer is almost everywhere. Whether you want to become an AI engineer, machine learning engineer, data scientist, data analyst, or generative AI developer, these concepts form the foundation of your learning journey. Many advanced topics such as neural networks, deep learning, computer vision, natural language processing, agentic AI, and large language models become much easier once you understand these fundamentals. And that is exactly why interviewers ask about them so frequently. So, the next time a hospital predicts a disease early, a bank identifies suspicious activity, or an AI assistant helps answer your questions, remember that behind the scenes, there is a system learning from data. Sometimes it learns from examples that already contain answers. Sometimes it discovers patterns on its own. And that simple difference gives us supervised learning and unsupervised learning. Understanding these two concepts is one of the first big steps toward becoming an AI professional. Thank you so much for watching. If you found this video helpful, please like the video, subscribe to Learn AI with Jay, and share it with someone who is starting their AI journey. Also, let me know in the comments which AI topic you would like me to cover next. Thank you for watching, and I will see you in the next video.